Hello, welcome. This is Birdy. Welcome to a new lesson in Houdini. Today we'll continue the new series Explosion in Houdini. Today we will build the fire simulation in Houdini. So let's get started. So let's continue, guys. Now, after we have the particle, now we need to make the sourcing for the pyro. So we'll choose pyro source. Okay. We need a fuel. It's already in the source fuel, but give us nothing because it's in the default. We have to change it to source any smoke, whatever source smoke. Let's then go back to the source fuel again. Now it give us the two fuel and temperature. We'll leave it on the default. We can have a temperature and fuel. Now we need to okay, now we need to make a volume rasterize attribute. We need boss to have the fuel, and we have the temperature, as we can see now. Also, we need to change something. Let's change here. Let's check the normalize by clamping change. And I think we can do minimum filter size, particle coverage. Yeah, and then delete the density. Couldn't make a difference, but normalized by clamping, it will give us the shape that we need. I don't like that it's stop. As we can see, the particle is stopping in its place and it's fading out or die. I want it to die while it's in its way. So let's go back to the pop network here. Yeah, as we can see, we'll go to the source. Let's change this to negative. Let's see the difference, if there will be a difference. Yeah, looks better. Let's go back. Yeah, same shit. Not working as we want. Let's change it to forward to see. Backwards. Maybe this one. Okay. Same thing. Okay, we'll leave it as it is for now. Now we have the two fields that we need: fuel and temperature. Yeah. We have the two field, fuel and temperature. We need the fuel at least to have an ignite. Okay. Also, temperature is good, but we can use the fuel field inside the DOP network and transform it to temperature, or convert it to a temperature. It will work as well. Now let's make attribute noise. It's a good idea to have an attribute noise. We need boss, we need fuel and temperature. I explained this in other in previous lesson, the attribute noise. So I'm not going to talk about it a lot, but just we need to have it 1D as a float, as a one number, because fuel and temperature is a float or a scalar. Yeah. So remap noise, this will add from -1 to 1. That's meaning it will be from 0 to almost 2. Okay. you want to check it, you can check it from here. Spreadsheet. Let's type fuel. Both will be the same. Fuel or yeah. Why it not give us a smallest number? Should have give us a smallest number. Anyway, we have it now. I don't. Yeah, we need to make it animated. That's it. Yeah, okay. But just I want this to still going and disappear. I don't know why it's doing this. Maybe there is something I forget it, but I think usually in the negative it worked fine here. Maybe I forget to make an ID or something. I don't know. Add ID attribute. Yeah, I add it already. Okay. Now we have the sourcing. Let's name it null. Name it out. Fuel or stand on it here back. Name this fuel source. Let's make a dop network. Sorry to the noise in the background, I apologize for it. Let's name this fuel no, not fuel. Let's name it explosion sim. Name it wouldn't make a difference. The name really doesn't make any difference. Just the name, just for organization. Organize the nodes. Now let's make the fire node 3 smoke object. We don't have a pyro object, we have only a smoke object. It will work. Now let's make a volume source. Let's change this to yeah, first let's choose source fuel to have a fuel temperature velocity. We don't have a velocity, so we can cancel it or make it 0. Both will make the same thing. I'll make it 0. Okay. This is first. Second, we need to address our browsing the in the sub pass here, browsing the explosion source. Here is out fuel. Now it will read. Let's do play to see if we have something. We don't have anything still. Why? Of course, because the smoke object doesn't read the volume. If we make it like this, as we can see here, it doesn't read it, and it's very small. It's very big actually. It's a big explosion. So I will leave it smoke object like as it is. I'm not going to change it for now, but I will find him. This is General Zod when he was speaking to Laura, that he will find Kal-El when she stole the codex. Okay, so not our subject. Let's focus, guys. Gas, resize, fluid dynamic. Here we go. Let's go to max. Let's uncheck the clamp. I explained this in a whole lesson just for the gas resize fluid dynamic. I hope you see it, you watch it if you don't know the gas resize fluid. Okay, previous, I think 55 or 45, lesson 45 or something. Now here we have a reference fields. Also we will have heat, because sometimes it doesn't read the heat. It doesn't the heat has a different value than the density, so I want to read the heat itself because the heat is bigger than the density. Or maybe the heat field will emit first, then the density after the heat cooling, it will change. It will become a density, a smoke. Okay, so anyway, we will have a heat because we have an ignition here happening. Tracking object, yeah, we'll have a tracking object. Hide other, check it again, still we have nothing. Okay, we have a tracking object to see if we have any yeah, here we go. Yeah, now we're talking, baby. Yes, we have now the let's hide other object. Yeah, we have the ignition happening, as we can see it now. Ignition happening, the explosion. Maybe I change the background to dark to see it more clear, and remove the uncheck the grid. Let's check it again. Yeah, we will increase the padding a little bit, because when we have the simulation or the particle or the field moving very fast, it can cut by the boundary box or the domain. So maybe we can make it to 5. Okay, so looks good. Okay, so it's working. Maybe we can make it, I don't need to have to make a delay. Maybe we can check the solve on the creation from the beginning. We don't need to make this, but we can make it. Okay, so I'm not going to check it to save more memory. But it's not the big change. Yeah, you can check it or not check it, be or not to be, doesn't make a difference. Doesn't really matter. Okay, now we have a division size. Let's copy the division size here. Copy parameter, back, go to the explosion, go to the pyro source, go to the volume and paste it here, voxel size. This relative reference. Now it's connected by the voxel size or particle separation in the fire simulation. Also, we can expand the. Actually, no, look good. We don't have to play with the particle scale. We can, of course, increase the particle scale, but we don't have to. Looks good. Let's go back. Okay, it's blowing like this. Okay. Now we need to change some stuff. First, let's make the division size is 1 to have better resolution, and of course we will reduce this number more to have better resolution and have more detail. Right now it's just a pillow, like a pillow, doesn't have any shape. We need to see the ignition, to see the flame and everything. We need to have a multi field. Of course we can choose the fuel here to see the fuel, to see the heat, but doesn't work that way. Better to have better to see it better, we choose multi-field. Go to multi-field. The smoke, the field that will create the smoke, of course, it's the density field. Density. Also the diffuse, for the fields, it's diffusing. Density. Let's go back. That's. I need one color. Maybe I pick it this color, dark color. This one. Doesn't look. Actually, maybe I'll make it light to see it. Yeah. Okay. Then we go to the emission. The emission is for the fire that we have. Okay. So the emission scale, it's about the flaming. This one is for the flaming. The flaming meaning the fire itself that will expand or emit or ignite, right? So emission scale, make it 1 to see it. Second, the emission field, which field we want to be our flames. Of course it will be the heat, because heat is the flame field, as we can see here. Second, the emission color. The emission color, we can take it from the temperature. The color of the color for the flame. We will change this to black body. Yeah, maybe we can temperature. Make sure you type it correct. Emission. What give us this emission dimension? Not sure why it give us this. Yeah. This is for demonstration only. It wouldn't affect. As we can see, the error disappeared. If you want to increase the intensity, all this only for demonstration, to see what we have here so far. Okay, looks good now. Maybe we can increase the density to 2. You know what? I will make it 1 to have better demonstration. Okay, let's go back. Now we need to start play with all what we have here. This is the explosion. Depend on the explosion. Let me, for example, do we need to have something here, or we want only the explosion happened and the fuel move and we don't have anything left here? So if we check the fuel stays in its place, then it disappears by time. Okay, if you want the fuel advect or move by the velocity of the explosion, we check the I think here composition fuel, we check the advect fuel. As we can see here now, the fuel is moving by the velocity or advected by the velocity. So if we choose multi It will give us, it will change. Yeah, okay. So this meaning the fuel is advecting by the explosion itself, meaning the explosion is moving the fuel as well. Of course, the fuel will burn, but also it will move. Okay, so like you have a tank, and when the ignite happened, does the fuel will move in the air and ignite, or it will stay in its place but ignite? So this is the difference between both of them. Okay, I think this looks better, maybe. Yeah, definitely. Okay, this is first. What else do we need to do? Of course, we need to do many things. Let's first start it. Okay, let's see the time. First, we need to have also a velocity. We still don't have a velocity that ignite, that advect the, يعني all this velocity from the simulation itself. All this velocity happening from the simulation itself, but we don't have the velocity from outside. So how can we do this? Very simple. We will make a bump source for the velocity. We're not going to import velocity. We will import something called bump. Bump is a velocity, but it happened in certain area. The velocity happened only in the density area. Okay, so let's make another volume source. This time we will connect it to the velocity update. Also, we can connect it. We can make a merge here and connect it with the volume source. I think both will be the same, but this time we will choose bump. Now we have a bump and velocity. Okay, we don't need a velocity. We only need the bump. So we need a bump from the source. We don't have. So let's go back. Let's go here. We have a pyro source here. Control C, Control V. Or you know what? I will simply copy all this and paste it here, as we can see here. Yeah. So let's choose custom. Do we have? No, we don't have a bump here. So let's name it bump. This is first. Second, let's copy this. Paste it here. Bump. Also, if you want to have any noise here in the bump, we can, but I think it will be 3D because bump is, I think bump is a vector. Give us as a float. I think it should be a vector. I think bump should be I'm not sure. Anyway, I will disable the attribute noise for now. Let's see if we have. Okay. Source fuel, source smoke, source color. I have a color here. We have something like this. Vectors. I think bump should be a vector 3. Yeah, I think we should check the vector attribute because bump is a vector because it's a bump, right? So I think now it will be a vector. Yeah, bump is a vector. I think bump should be a vector. Yeah, we should have a bump here. This is called fuel. Let's go back. Yeah. Okay, I'll make it multiple, something like this. Yeah, I think it's working now. It's becoming much and much bigger. So it's working. Maybe just I need to change its name to bump. We don't have a velocity. We'll uncheck the velocity. Yeah, we have only bump. Let's continue. Now let's start to play with the change the shape of the explosions that we have. Okay. First of all, let's change the simulation self time scale 1. Okay, temperature diffusion. Depend of the shape that we want in the temperature diffusion. If we need it's the same thing or different, maybe we can make it less temperature diffusion. I will leave it in the default. Cooling rate. Cooling rate for the temperature. Do we need to have the temperature leave more in the smoke or not, or leaving more on the, so we have more fire? So I think I will leave it in the cooling rate maybe 0.8 for the temperature to live more in the simulation. Viscosity, we don't need any viscosity. Bounce left, maybe I will make it like 3 and make it 1 in the direction of y. Okay. Second thing is the composition. Ignite temperature. Ignite temperature meaning I explained it in the before previous. So anyway, I want all the fuel to burn or ignite. Okay, from the beginning. This is first. Second, burn rate. I want to burn all the fuels that we have. Burning rate is very high. I want to burn rate the fuel efficiency. If we want any fuel to remain to be ignite, and if we have a big number here, that's meaning we will have a fuel that will remain more, so it will give us fire longer. The fire will live longer, okay, or the fuel will live longer. So it depends really in what do we want to do. Okay, I will make it 0. Temperature output, I think I will leave it as it is. I'm not going to change it. This explosion is so big, so huge. Okay. Let me make sure. Okay, so gas release, which make the gas expand, or the explosion expand more. So if we put a small amount here, we're not going to have a big explosion, as we can see now. Yeah, I think 5 looks good actually. Actually, this looks much better. Yeah, okay. So let's continue. Flames. The height of the flames, if we need the flame to stay much longer in the smoke itself, maybe if we make it 4, it will live longer. Okay. As we can see here, it live much longer. Cooling field temperature, I'm not going to change it. Cooling, okay. Then let's go to the smoke. I need to create dense smoke. As we can see, the smoke become more dense. Smoke amount, let's make it 4. As we can see here, the smoke become much and much dense. Okay. Heat cutoff, which stage we want the smoke becoming a fire, the fire becoming a smoke, depend on the heat cutoff. This is the value of the heat cutoff. When it's 0.2 or less than that, it will convert to a smoke. We can make it 1, so the fire will live longer. As we can see, it's becoming different. So the heat will take more time to becoming a smoke. Okay. Blend the amount. You know what? I will make it default. Doesn't make a difference. Gas dissipation, flame contribution. I will make this one. I'll make this 0.2. Let's see the difference. Looks better. Temperature, not going to change it. Fuel, already I changed it. If I want the fuel to move faster, I can make this as a 1. Let's see. So the fuel will advect much faster, as we can see. Looks good already. Let's make it, of course, for the demonstration, let's make the smoke a little more dense. Let's make it 2. Yeah, to have better demonstration. But as I say, it's a demonstration. It will not going to affect of the dense of the smoke, just for a demonstration only. Let's go back. Yeah, okay. Now what we also need to do, looks good, maybe 0.5. Yeah, all this parameter you can play with it until you have a better okay. Now let's change the shape. As we can see, first we have a dissipation. I will leave it as it is. I'm not going to change it. Second, we need a disturb. I need a disturb to 0.9. This is a disturb. If I need to use a field to control it or not, depends really in what do you want to do. So disturbance, if we want to choose a control for the disturbance, and this is the cutoff. First let's see, what we have here so far. We have much and much detail, as we can see here. If you want to have many size for the disturbance, we can choose a micro solver instead, but for now I will just use this one. Edging, use control. We can use it the disturbance from the velocity. Let's choose, if we choose the will, let's see what's going to happen. Here the disturbance in everywhere. When we choose a control setting, it will put it only in a specific area. Okay. Okay, I will leave it as it is. Shredding. Let's make it 1.9. Shredding. Let's make the stretching one as well. Nice. Yeah, but it's so. Let's make it for the default. Point 7. Sharpening. Maybe increase it a little bit. Turbulence. Also, we need a turbulence, but we don't need too much turbulence. Maybe okay. Put it. Density. Okay. Let's see it. Looks good. Also, we'll have a confinement. Confinement, we will use density here. Density. And also maybe the disturbance. Okay, so let's see it again. Looks good already. Yeah, but maybe shredding, I need to make it maybe 1.5. Maybe a disturbance on the velocity. Okay, I think it looks good already. If we want to have more, of course, if we want to make the smoke, the gas bounce, maybe make it. I will leave it as it is. I'm not going to change it. So I think this. Maybe we have shape. Temperature. Temperature. Okay. Looks good. Yeah. So I think last thing we need to do is finishing. just maybe I can add the gas vortex confinement, but I already have a confinement, so I don't need to add it. Just I will add receipt also here. I go to advanced, add receipt, and also we can make the max step to 2, also here too, and also last thing what I need to do, oh yeah, make it 0.3 to give us better resolution. And that was it for this lesson. I hope you enjoyed. If you have any question, please type it in the comment section below. Also, don't forget to subscribe to the channel and like our video and share it with your friends. Also, if you'd like to support us, you will find below the video a link on Patreon and Gumroad, and we appreciate your support. And I see you in the next lesson. Have a good day.